In Chapter 10, we discussed descriptive statistics. These are used to describe the characteristics of a sample. You cannot make any inferences based on the results. In this lecture, we are going to talk about inferential statistics. Researchers can make inferences about a population based on the data obtained from a sample. Here are some basic facts of inferential statistics. First, it allows researchers to make inferences about a population based on the data obtained from a sample as mentioned above. This is what inferential statistics are about. Remember when we discussed sampling, we stated that researchers hope to obtain a sample representative of a larger population. Such samples enable us to make inferences from the sample to the population. This lecture will introduce the basic concepts of inferential statistics. You will not be required to know how to calculate these statistics in this course. It is reasonable to assume that each sample will give you a fairly accurate picture of its population. However, samples are not entirely identical to the parent population. The difference between sample and population is what is known as sampling error. If you take samples from the same population, we could seldom obtain two samples with the same characteristics. This graph nicely addresses the concept of sampling error. In order to deal with sampling error, we can collect a large number of random samples using the same sample size from the same population. If the collection is large enough, these samples can be arranged into patterns that will allow researchers to predict accurately some characteristics of the population. Please note that researchers do not need to collect these samples, as long as each sample size is large enough, normally more than 30. The distribution of the sample mean is then normally distributed. Check the beautiful bell curve. We normally call it sampling distribution. The sampling distribution has some nice features. The mean of the sampling distribution is equal to the mean of the population. We can think about sampling errors through the sampling distribution. Remember that we checked the variability of distribution through our study of standard deviation in Chapter 10. To check the variability of the sampling distribution, we use standard deviation of the sampling distribution too, which is called standard error of the mean. It follows normal distribution and the 68, 95, 99.7 rule. This is the foundation of inferential statistics. In the following slides, we will introduce confidence interval and hypothesis testing. Confidence interval is a region extending both above and below a sample statistic, within which a population parameter may be said to fall with a specified probability of being wrong. Standard error of mean can be used to determine boundaries or limits of the confidence interval. The confidence interval is set up by researchers. Normally, researchers report 95% confidence interval, which is connected with the two standard error boundaries. It indicates a probability that 5 out of 100 population means would fall outside of the boundaries. Again, we will not cover how to calculate the confidence interval. You only need to understand the concept. Hypothesis testing is a way of determining the probability that an obtained sample statistic will occur in a given hypothetical population parameter. Our research hypothesis specified the predicted outcome of the study. At this point, we will also see reference to a non-hypothesis. Our non-hypothesis specifies that there is no relationship in the populations, so typically that's the hypothesis that we are trying to disprove. Let's review the steps of our hypothesis testing. First, we need to identify the research hypothesis and the non-hypothesis. We need to determine the sample statistics pertinent to the hypothesis. Then we need to calculate the test statistics to determine the probability of obtaining these statistics. This is obtained based on the sampling distribution we just introduced above. If the probability is small enough, we reject the null hypothesis and affirm the research hypothesis. If not, we do not reject the null hypothesis and do not affirm the research hypothesis. We need to use a significance level to decide if the probability is small enough. We will introduce that in the next slide. We are normally concerned about the practical and statistical significance of a hypothesis test. Significance level refers to the probability of a sample statistic occurring as a result of the sampling error. It is commonly used at 0.05 level. This is related to our statistical significance. Practical significance determines if the effect is large enough. It is checked using effect size. Statistical significance and practical significance are not necessarily the same. The results of a statistical significance finding do not mean that it is practically significant in educational sense. There are different effect size indices for corresponding statistical tests. We may have one-tailed or two-tailed testing. A one-tailed test is when the researcher obtains a positive or negative difference between the sample means, which will support the hypothesis when using only the positive or negative tail of the sampling distribution. A two-tailed test involves using both sides of sampling distribution because the research hypothesis is not directional. We may have two types of errors in hypothesis testing. So, a null hypothesis predicts no relationship. A type 2 error occurs when the researcher fails to reject the null hypothesis that is false. A type 1 error occurs when the researcher rejects the null hypothesis when it is in fact true. Both of these are certainly problematic and important to avoid, but we approach them in different ways. Researchers hope to balance two types of errors in their studies. Power is the probability that the test will correctly lead to the conclusion that there is a difference when in fact a difference exists. Let's look at an example together. There are diverse inferential techniques available for research studies. It is imperative to figure out what tests you need based on your research questions. Parametric techniques make assumptions about the nature of the population from which the samples involved in the research study were taken, whereas non-parametric techniques make a few exceptions about the nature of the population from the samples are taken. Normally, non-parametric statistics are for studies with small sample sizes. The sampling distribution discussed above is for parametric techniques. Please review these basic parametric and non-parametric tests in the textbook. Again, this is just a broad overview of the way in which we can analyze the data. You can enroll in EDRM 710, 711 for parametric techniques and EDRM 712 for non-parametric techniques. You might feel a bit overwhelmed with the last two chapters if you have not taken a statistical course before. Don't worry, as I have stated many times, a good understanding of basic statistical concepts is all that is necessary at this point. When you come across related terms in a research paper down the road, you will recognize those terms and understand the basic concepts. For instance, I might ask you what are the characteristics of sampling distribution? What is the difference between practical and statistical significance? When you take a statistical course in the future, you will learn how to calculate different test statistics. This is the end of this lecture. Thanks for watching. We will conclude our discussion of statistics in Chapter 12.